Okay, for the first part in this simulation of section R.5 part 1, okay, we have among the problems we have quadratic equations, and here we have in this particular case, all right, we have looking at solving for u, whereupon we have 4u to the second plus 9u is equal to -2. And we have for this equation, we do not have this set up in standard form, but I can make a quick fix of this upon adding 2 to both sides. And so we have, in effect, okay, we have 4u squared plus 9 times u plus 2 is equal to 0. And here, this is one you can factor by grouping, or you can do a few attempts at factoring. Okay, so you have 4u squared. Now this might have gone to 2u and 2u, but here this is going to go to 4u and u. And for factors of 2, where upon the outside and the inside products will add up to 9u. So we have to sequence this just right. And it's going to turn out that we will have 4u plus 1 and u plus 2. Again, if you FOIL out, we have 4u squared. Outside product, we have at 8u. Inside product, we have at 1u. So they add up to 9u. Last product, we have at 2. So we have for 4u plus 1 equal to 0. Okay, now we have 4u equal to -1. And we have the first solution. We have a -1/4. And as for u plus 2 equal to 0, okay, we have that u is equal to -2. And reverting to what we have here, so we have -2 as one solution, and we have with the fraction, which in this case, you either have the negative in front. Okay, so we have -1/4 and checking, and that is correct. Okay, for the next item, okay, we have the quantity of y plus 7 raised to the second power minus 44 is equal to 0. And upon adding 44 to both sides, now I have this set up whereupon I can utilize, okay, the square root property of equality. Okay, so if I go from the square of y plus 7 to just y plus 7, we have with 44, we take positive and negative, the square root. And now, so you have y plus 7 is equal to plus or minus the square root of 44. Now, for 44, the amount is not a perfect square, but it is nonetheless the multiple of perfect squares higher than 1. Okay, so for the square root of 44, okay, highest perfect square we can take into 44 is going to be 4. So you have 4 times 11, and so branching out, we have the square root of 4 times the square root of 11, so this will become 2 times, okay, the square root of 11. Okay, and so we have y plus 7 is equal to plus or minus 2 times, okay, the square root of 11. So you have y plus 7, you have minus 7, and subtracting 7 and placing on the other side, I will have this position in front of the radicals. And so we will have, for y, okay, we have 2 solutions. Okay, so one we have at -7 plus 2 times the square root of 11. And also we have -7 minus 2 times, okay, the square root of 11. So, and just putting back in and seeing how this is going to work. So you have -7 plus 2 times the square root of 11. You have comma, -7 minus 2 times the square root of 11. And checking out the results here as a third case. Now we're crossing over to using the quadratic formula. So here we have 2x squared minus 5x minus 1 is equal to 0. And for what we have for the ABC values, okay, so a is equal to 2. and we have b is equal to -5, and we have that c is equal to -1, and substituting, so we have negative b, so we have the negative of -5, and we have plus or minus, okay, the square root, and we have the square of -5, we have -4 times 2 times -1, and we have all over 2a, okay, so we have it 2 times 2. And for what we have inside the radical, so you have -5 squared is going to be at 25. -4 times 2 is -8 times -1 is going to be a +8. And so taking what we have in the case of x, okay, now I'm going to itemize an Aleks, but you have in compact form, we have 5 plus or minus what is going to be the square root of 33 all over 4. Okay, so just carrying over to what we have here. So you're going to have at the one end, okay, we have 5 plus, and we have the square root of 33. Okay, now you're going to have everything all over 4. So in the case, one way of formatting, okay, so if I highlight, we have all over 4, and let me mention, okay, and if you don't use that fraction encoder, okay, if you don't use this one, okay, so you can take what we have here. See, we have, if you're not going to use this, okay, and we have for the other solution case, you have 5 minus the square root of 33, and that's going to be all over 4, and checking the result, and that one is correct. And we have for the next statement, okay, we're looking at restrictions, and it says to find all excluded values for the expression. That is, find all values of v for which the expression is undefined. Okay, so we have v plus 8 over v squared minus 49, and so you have v plus 8. And if I were to factor this difference of squares, so you have v plus 7, quantity times quantity v minus 7. Now for this expression to be defined, we have v plus 7 and v minus 7k. Those cannot be 0. So we had that v cannot be -7, and we had that v cannot be 7. So these are our restrictions. For what we have regarding v, okay, the restricted values will be at negative and +7. Okay, so referring back to what we have now, so we have for v, okay, have -7 and 7, and checking the result, and that is correct. Now, and we have for the next item, okay, so we have an equation, and we're looking at solving for v. Okay, so we have for this one, okay, so you have 1 over v minus 5 plus 2 over v plus 4, we have is equal to 3. Now for v squared minus v minus 20, I can just write this trinomial in factored form, whereupon we have v minus 5 as well as v plus 4. So just looking at clearing out the fractions. Now we have for the least common denominator, okay, we have the quantity of v minus 5 times that of v plus 4 okay, so just multiplying all the ratios out. And we have, upon working these out, So we have in the reduction, okay, first ratio, v minus 5 is going to go out. Next, okay, v plus 4 is going to go out. And then we have for the last ratio, we had the complete cancellation of the least common denominator. So for the terms that remain, you have 1 times v plus 4. And we have 2 all over the quantity of v minus 5. And we have is equal to 3. And before I go any further, let me mention, okay, now for the restrictions, v minus 5 cannot be 0, so v cannot be 5. Also, v plus 4 cannot be 0, so v cannot be negative 4. Okay. And so looking at proceeding with what we have after having cleared out the fractions. Okay, so you have v plus 4, and we have plus 2v minus 10 is equal to 3. And combining like terms, so we have 3v minus 6 is equal to 3. And we have, upon adding 6 to both sides, we have that 3v is equal to 9. And we have in the result with division by 3, we had that v is equal to 3. So it satisfies both restrictions. And looking at testing out what we have here, so we have for v at 3 and checking, and the result is correct. And for what we have here, now the least common denominator, this will be the product of w minus 1 and w plus 2. And multiplying all the terms out. Okay, so you have 4 will be multiplied by w minus 1 and w plus 2. And you have plus. Again, we have w minus 1 times the quantity of w plus 2. And you have times the quantity. You have 5 over w minus 1. Okay, so just looking at what we have in the process. Okay, so we have 4. Now we have w minus 1 times w plus 2. Now for the trinomial, we have w squared, and what's going to be plus 2w minus w, which will be w, and we have minus 2. Now for clearing out the denominators, okay, so we still have 5 times the quantity of w plus 2. And for 1 over w plus 2 cancels out. So you got 1 times w minus 1. And looking at what we have here, so you have 4w squared plus 4w minus 8. 5 over the quantity of w plus 2, so this will be 5w plus 10. And we have is equal to w minus 1. And joining together like terms, so you got 4w squared, and what's going to be plus 9w. Negative 8 plus 10, okay, so this will be a plus 2. And we have is equal to w minus 1. And so forming a quadratic equation that will be in standard form. Okay. So we're going to have in the mix, so you have 4w squared. 9w minus w is going to yield 8w. 2 plus 1 is 3. And we have is equal to 0. And we can factor this particular expression. And in fact, what's going to happen here, you could do the factoring by grouping. And for 4w squared, when you had this, go to 2w and 2w. And we have, say we have plus 3 and plus 1. Again, you can do the factoring by grouping and setting 2w plus 1 and 2w plus 3 equal to 0. So we'll have 2w equal to negative 1 and 2w equal to negative 3. So we have with these, Okay, we have that w is equal to -1/2, and we have that w is equal to -3/2. And just looking at what we have now, again, you have for the restrictions on w cannot be equal to 1, and since w plus 2 cannot be 0, w cannot be equal to -2. So just checking what we have here. Restricted, we have 1 and -2. And we have for those values in w, we don't have any of those restricted values. And so they're going to work out. So for -1/2 and -3/2. So we have -1/2 and just checking the results. Now let's say that for what we have in this remaining case, okay, so you have 3x squared, and I'm just going to write this in factored form. So you have with x squared minus 4, so you have the quantity of x plus 2 times the quantity of x minus 2 is equal to 3 over x minus 2, and we have plus 4x over x plus 2. So looking at attempting to solve for x, now again we have the least common denominator. We have the quantity of x plus 2 times that of x minus 2. And for the restrictions, again now x plus 2 cannot be 0, so x cannot be at -2. As for x minus 2, if that cannot be 0, we have that x cannot be at +2. And what's going to happen here, if I were to multiply everything out by the least common denominator, okay, so x plus 2 and x minus 2 would cancel out. So left hand side, we have a 3x squared. Now for 3 over x minus 2, if I multiply by the least common denominator, x minus 2's would cancel, but I'll still have an x plus 2 factor left over. And as for 4x over x plus 2, if I multiply this ratio by the least common denominator, x plus 2's would cancel, but I will still have 4x distributed over the quantity of x minus 2. And so we have here, we've got 3x squared, and we have with the distributions, so you have 3x plus 6, 4x times quantity of x minus 2, so this would be 4x squared minus 8x, and we have upon combining like terms together, so we have 4x squared, 3x minus 8x becomes -5x, and we have plus 6. So if I take 3x squared away, so I have 0 is equal to x squared minus 5x plus 6. And in factoring, okay, so I have 0 is equal to the quantity of x minus 2 times the quantity of x minus 3. And for the attempts at solutions, upon utilizing the zero product property, okay, so you have one apparent solution is going to be at x is equal to 2, and if I set x minus 3 equal to 0, we have that x is equal to 3. And if you notice with x equal to 2, this is one of the restricted values, so this is disqualified, but with 3 not restricted, this is going to end up as the only solution. Okay, so if I go back and check what I have in the results, okay, so we have for x is equal to 3, check out.